Good afternoon, everyone. In today's video, I will be showing you how to model a parametric lighting fixture by using Dynamo and Revit. In this tutorial, it's just the model I'm making is fully depending on the spiral system or circular array that we actually detailed in the previous videos in my Dynamo playlist. So if you want to go back and check the related topics, I'll try to leave some links here for you so you can go ahead and revise. The model can be worked actually as a lamp, and could be a table lamp, standalone, or it could be just rotated 180 degree and work as a lighting fixture. It's all based on the same concept. I don't claim that I designed that. I actually saw that on Pinterest or Facebook, and sadly I tried my best to find the model that I inspired this geometry from, but all waste. I couldn't find the original document actually, sadly. Anywho, so the model can change parametrically to lots of options. Those are just sample, starting from 1 meter high to almost nothing in 180 degree, or 360 degree, or 720 in all options and all radiuses. You can control the thickness of those fins and the rotation, the numbers, the location of the lamp, almost every single detail within a couple of very basic nodes. Lots of samples that I have, all inspired from free images you can find on web. This is one very similar to the one I'm modeling, by the way, if you rotate it 180 and fix a cable to it, especially this one. So yeah, you can do the same thing, I think, but there's an extra part of that. So without it, it will be very similar to the one that I modeled right now. And again, in Pinterest, you can find lots of similar concepts. I'll try from time to time to model those or part of those available in internet, and try to see how that goes. Anyway, so back to our topic. I prepare the nodes already, and I just hide them, and I'll try to explain in a very basic steps how to model that. So in order to generate this type of model, you need a point by cylindrical coordinates, and of course you need an angle, elevation, and radius. I'll depend on the basic or the default coordination system in a 0, 0. So the angle can be specified by you, of course. So it will be fed by a fader here, or a slider, and the slider here specifies 360 degrees, or full circle, and it will be fed to a value of A. So that's a range from 0 to A. And if you open that, it will generate values for you, numerical values that started from 0 and end to a 360. And to allow the user to determine the amount of fins, or the amount of small pieces of food that's rotated around the object or in the lighting fixture. Here I have a 20, for example. So the jump and the numerical jump of each that, or the overall values of the fin, should be set by this formula, and eventually going to have a rotation from 0 to 360 with an overall 20 elements. That's how we do it. This is a range. That's the start, which is 0. That's the end value fed by you here, and those are the amount of jumps specified by the value of B. All those to be given to the angle. So we specify how many elements will be located at each angle. And I will open that to preview. That might help you to digest this first information. And probably we need to zoom out also. So you can see the spiral generated. If you look at it from top of view, I believe that Autodesk now really need to provide us a top of view, like a view box here in Dynamo, rather than this painful way of rotation. And you can see that the rotation is, if you look at it from the top view, it's actually 360 as a rotation, and that's the thing. And you have, if you want to count them, you have 20 points. Now the other thing to specify that spiral or helix, whatever you want to call it, is the elevation. and the radius of it. The radius is here fixed, it's not been changed, set to 0.2 for all the points at the same value. That's a fixed value here and not a range. And the elevation in this is actually changing to provide this spiral shape. And again, it's a startup from A, which is, I didn't put 0, so you get more option. If you put 0 like what you've done, you're going to start up from 0, but you're going to you have less option. It will be constrain you to start always from a 0 value, which is a fin that doesn't have, or a point that doesn't have any height, which is not nice all the time, unless you want that, of course. So I'll start up from a specific variable, which is here I said it's a minimum elevation, and the maximum elevation is the end of the range. So it will provide you here very close range from 1.4, oh actually it's a big, it's a unit is meter, so from 1.4 meter to 0.2 meter. So yeah, it's a wide range of height, difference in the height, and each jump will be set, or the overall amount of jump will be set of a C, a numerical value, fixed value, which is a 20, which I gain also from the same number of fins. So the amount of fins that I'm going to feed will be the same amount of points, will be the same amount of values given to the height. And that's very important to keep the consistency between, you know, the elevations and the rotation angle in the same time. Now I'm going to close those two things because I bet now you understand what they do. And that's the first thing. That's the first, helix. Now we need a second helix. The second helix, if I want to go back, will determine, the thickness of those. If you zoom in here, you find that there's a thickness for each fin. So how to do that again is to set another, another set of points. And if I open that, get that out of the preview, you will see that those set of points are also, related to the original one, and they all go to the same center. So they're also like a cylindrical system that goes toward the center of that helix. And the difference is that they have been like offsetted with a specific value. So what's happening here, they both have, I think the same, yeah, they are both. If you can select this one. So the value for the angle are the same. The elevation is, I think, is different. Radius is different, actually. The elevation part is the same. So if I select this one, see the elevation for them is the same. That's what I want. If you want to change it, it will be inclined fin, not a straight head fin. And the angle is the same. The only one difference is the radius. So the radius will be taking the original radius set by you here, and it's going to add for it, the fin depth. So if you can see here, that's, if I select this one, this formula, I'm getting the fin depth, let's say 0.02 meter, and add it to the value of the radius. So it's 0.22 if you want to look at it that way, and you set it back to the radius. And if you look at the depth of that, I can change it to 0.05, and they're going to jump to create a thicker, it's not a thick, it's like a more depth fins. So that's beautiful. I'm going to set it back to 0.2, and that is better, I think. Now we need those two sets of points. We need their projection on the 0, 0, the XY plane. And how to do that? It's super easy, which is having the same set of points and have the same set of angle and radius, except that we are cutting out the elevation. So just copy those two things that we've done up and remove the input for the elevation. That will keep it or restore it to the default value of a 0, causing us to have the projection of those on the ground or on the XY plane. And that's exactly what I want, to generate a set of rectangles or a quad point system, whatever you want to call it. So now, if I open this list, which I don't want to be honest, because it's going to keep, going to generate 4 sublists. Each list will be containing 1 helix. So this is the first one, the inner one. And if I'm closing this and set this one, this is the outer helix. All right. And the other one is the inner one of the projection of the inner one. And the third one is the projection of the outer one, which completely make no sense and no benefit for us. We need those, those lists to, I need to take a first point of this list with the first point or first element, of this list, and so on, to create quad system, to reverse or transpose this list. And this is exactly what this guy will do. Okay, so it will create a smaller list made of 4, and that's what I want, 4 exactly 4 points. So this one, which for some reason it doesn't show. Oh yeah, because it's off. Sorry, my bad. Okay, so I'm gonna off this one. So if I have those points, this is 1 and this is 2, which is God knows where. It's either go that way or it goes to its projection, and then the third one here. So this one up, actually 1 here, this one, and then it goes to the second one, which is the depth of the fin, and then it goes to its projection of the outer one, and then to the inside of it. So it's gonna just draw a vertical rectangle, which represent the center or the rectangle that will be later on be extruded to generate the fin. So again, I'm gonna turn off that, and again I'm gonna hide it. Too much points, which I don't know. I don't need. Now I'll generate a polygon. I just undo, and I go preview. So if you can see, now things start to make more sense as it's better visualized, as you can see. These are the depth of the fin, and that's their projection, and those are the rectangles. Otherwise we're going to be having 4 helix, making almost no benefit for us. This guy is the final thing, which is going to make extrude based on the depth value or the distance value that you can provide us. I'm calling it thickness. So we need to activate it so we understand what are we talking about. Let's go ahead, open this guy, and as you can see, I have no need anymore for the polylines, and all I need is those boxes. As you can see here, they are beautifully placed, and you can control and flex everything you want. Come here, just make this point 001, I think. Yep, 0.005, I don't know. Can I change with this? Yeah, I don't know why I didn't use this one from the beginning. It makes no sense. So this one on me, so you can see that you can control the depth of this thing and the thickness of it, whatever you want. Actually, you can control. And again, the depth of that, you can also go ahead and design whatever you want. That's the concept of parametric and generative design. Whatever type of elements you do, whether it's building or a lighting fixture, you have to think of designing the process, not to design the one element in your head. You're going to end up by having the algorithm that allow you to model infinite possibilities of geometries instead of one that you was thinking about. Anywho, so that's beautiful. And again, if I want to test the rest, is that a wrap or something? You see this? All right, and we can control the rotation and make it 180 instead of 360 to have half. That could be also used for a pavilion design and exterior elements. Yeah, I get a new idea now. Number of fins, you can go ahead, increase. Okay, depend on how fast your machine and how much money you got to bear with those changes. Minimum, You in maximum can make it that's 0 or close to 0, and try that crazy thing when you go for over 180, let's say 720, so 2 loops, and that means you need more fins, of course. And you can see this crazy, you know, we start up to have an infinite possibilities of shapes, design, depend on your design, depend on your thoughts. You design that, and you know, also the radius can be controlled. I don't know, 1440, even crazier. Yeah, the more loops you make, the more elements you have to add. So I'm gonna get back to 720 maybe. Nah, I'm gonna go back 360 to be honest. Okay, and you see that there is an infinite amount of possibilities. It depends on what's in your head and what do you want to design. Again, the minimum height, maximum height. I think I wrote that in reverse order. This should be the minimum. That should be the maximum, and that should be the minimum. Yeah, that's crazy, isn't it? Yep, no one see this mistake, only my 8,000 subscriber. Yeah, don't tell anyone. Anywho, so 0.2. Yep, you can see that's the minimum, definitely. That's my bad, that's my mistake. All right, so too much fins, so probably 75 is enough. All right, I don't know, 50. Yep. Okay, so this is almost it. You know, that's the shape, the important part of the shape. The rest is super easy. Is basically you know, a base and holder and the light bulb. Very basic shapes, a very basic sphere actually to represent the light bulb. Let me start up with you for the base. So what is it? First, I'm making a point, and so I'm gonna get the preview. This is a normal XYZ point, and I am raising it. I think I need to get rid of all those fins because they're gonna block your view, which making the overall understanding process is much more harder. So let's go back and make those not 8. Don't be stingy. So just jump forward, make it 8. It's too few. Now that's better. So you have, you know, better understanding of what I'm doing. So at this point, this dude here, little guy, is being controlled by this point, which is this one, raised from the 0, 0 by the base height, so you can control him. Here you go up, you can go down, do whatever you want. Then I'm creating a plane out of that origin. Of course, I'm going to hide the plane. And then from on that plane, I'm actually making a circle. So this is my circle. Why did I get the plane again? Okay, I think I'm hungry. So this is the circle. Again, don't tell anyone that I did this mistake. That's the circle. That has the same radius that the spiral has. So whatever value you provided right here in the radius, right here, it will be the same exactly that I use for creating the circle. And from the circle, it's just basic extrude, my friends. You know, and that's it. That's the cylinder that represents the base. And then I'll be using a translate, geometry translate. So I'm taking a copy of the point that I have down here. I don't know what I've done. Show labels, I mean show preview instead. I'm completely useless today. Anyway, so this is the point. I just push it up by the base thickness value. So you can push it up if you want and change that. I'm not going to do that anyway. And then again, I created a plane, and then I created a circle, and I control the radius of the circle here by the holder radius parameter or slider. And then, as you know, Uncle Extrude will do the job. And the same thing for the lighting bulb. It's just a basic representation. I didn't pay too much attention to it, to be honest. So the geometry translate this time. Let me open the preview for it, also to determine what? To determine the points. And here you can see I added the same holder height, which is the holder height that I provide for the extrude right here. You know that there is a value of the extrude for that. I multiplied by 1.2. It's kind of gonna crash at some specific point. And as I said, I didn't put much attention to it. And then the light bulb itself, which is just a sphere dot by center point radius. So just put that on. It gets you the shape of the lighting fixture. It's look like, sorry, the shape of the light bulb, I mean. And I thought of that in the beginning, maybe remove, get this shape, I don't know, or undo, keep that way, I don't know, because if you're going to stretch that in a specific level, of course, the overall length will be more than acceptable to be, you know, make sense like this relationship. And the 1.2, the ball will be look like floating in the air. So you have to find better formula for this one. I'm too lazy to do it. But that's it. That's overall it. You know, very simple one. Very simple algorithm or nodes. And you can get almost any shape you want out of that. You can reverse that to get the lighting fixture and hold it to the ceiling, or make it like this standalone or a table lamp. It depends on your thoughts and your ideas, and get these possibilities that I'm showing here in the advertising or the ad paper. Anyway, I do appreciate if you can, if you like, of course, the video. I appreciate if you can hit like button and drop some comments. And also, if you are interested, and really appreciate if you can have a look at that book. If you can buy, if you are interested in Revit parametric design, that's my book in parametric modeling, mainly for beginner making Revit families. It have lots of concepts and definitions and practices to make basic furniture, and teach you how to make an from basic to advanced concept range and Revit parameter. It's not about Dynamo, I know, but it's more like an architecture and interior guide for making the basic or understanding the basic of furniture concept range and how Revit family actually can work to and with us. Anyway, guys, thank you very much for watching. Thank you very much for supporting me, and have a lovely afternoon. Bye bye.